Hello everyone, welcome to the channel. Today we'll be talking about the ancient Indian scientific instruments by Aryabhatta, Bhaskaracharya and Brahmagupta. Join us for an illuminating discussion as we delve into the ingenious instruments crafted and utilized by the eminent Indian sages Aryabhatta, Bhaskaracharya and others. From revolutionizing astronomy to shaping architectural marvels and aiding in surgical precision, these ancient tools hold profound significance even today. So let's meet after the intro. Explore the remarkable legacy of ancient Indian sages through their ingenious instruments like the Ghati Yantra, Shanku Yantra, and Shulba. Join me and Mr. Radhakrishna Warrior and distinguished panel members including Eashwar Thyagarajan, Pandit Mahesh Shastriji as they unravel the mysteries behind these timeless creations. Gain insights into how these instruments revolutionized fields such as astronomy, architecture, and surgery, leaving an indelible mark on human history. Let's invite our first guest, Radhakrishna Warrior, who is an engineer by profession and is deeply interested in such non engineering subjects as ancient science, modern science, history, linguistics, astronomy, and anthropology as related to Bharat. Originally from Kerala, India, Radhakrishna ji obtained his bachelor's degree in electronics and telecommunication engineering half a century ago and immediately afterwards joined the Indian Space Research Organization, which is ISRO, as a young engineer. After working at ISRO for 21 years in the field of radio frequency and microwave communication as related to satellites and launch vehicles, he continued his career abroad. After working for many years in Canada in the same RF and microwave communication field in different companies and in different cities of Canada, he came to the US 9 years ago. He has been living with his wife in the city of Renton for the past 8 years and has been working in the field of radio frequency and microwave communication for positive train control. His son, daughter in law, and two young grandsons live in Halifax in Canada. Let's invite him. Hello, Radhakrishna.
Namaskar.
How are you?
I am very fine.
Okay, next, let's invite Mr. Eashwar Tyagarajan, who is a student of Vedanta, Itihasa, and Puranas for several years, and he has been a great engineer for more than 25 years. Hello, Ishwarji.
Namaste, Shruti ji. Namaste, Radhakrishna ji.
Last but not least,
Namaskar.
let's invite Pandit Mahesh Shastriji, who is the Panchang Siddhanti of mypanchang.com and has prepared Panchangam calendars of 90% temples in the United States.
Pranam,
Hello.
Radhe Radhe.
How are you?
I'm fine. And how are you all?
Namaste, Mahesh ji. Namaste. We are all good.
We are all fine.
Awesome. So before kicking off this conversation, Ishwarji, I want to request to start with a prayer.
Okay. Om Shuklam Baradaram Vishnum Shashivarnam Chaturbhujam Prasannavadhanam Dhyayet Sarva Vignopashantaye Saraswati Namastubhyam Varade Kamaruvini Vidyarambam Karishyami Siddhir Bhavatame Sada Jnananandamayam Devam Nirmalasvatikakritam Adaram Sarva Vidyanam Hayagrivam Upasmahe Gurur Brahma Gurur Vishnu Gurur Devo Maheshwara Gurur Sakshat Parabrahma Tasmai Shri Gurave Namaha Om Shri Gurubhyo Namaha Harihi Om.
Awesome. So before kicking off this conversation, I do want to let all of our viewers know that please ask questions as we go. हम लोग सबके questions ले लेंगे, किसी को भी नहीं छोड़ेंगे. So as you go along with us and you have questions, please ask us. We have a very, very able panel today to be answering all the questions that you might have. Okay, so to kick off this conversation, Radhakrishna ji, I'm gonna bring up the slides first. And we'll be talking about the ancient Indian measurement instruments. And I guess India may to, for several years, like I shouldn't say years, for centuries, astronomy has really been a big deal. I think there has been a lot of night sky observation. We knew about zodiacs. We knew about so many things. So I think for all of this to happen, there has to be a basis through which they explored these things, right? And obviously, that basis lies in our ancient sages who have done a lot of research.
Yes, indeed. Actually, this started even right from the Sindhu Saraswati civilization days, and that's more than 4,000 years ago, or even much more earlier.
Right.
And all those well-planned cities, all those they imply precise measurement
Mhm.
and standardization. Everything should be standard measurements, length, weight, everything. So, and the Sindhu Saraswati civilizational area was vast, quite vast. It's not just Harappa and Mohenjo-daro. It's a vast area and starts right from eastern Punjab to maybe Uttar Pradesh, and then
Mhm.
as south as Gujarat, Lothal, and such areas. So it's a very wide area, and in that wide area, there
Mhm.
was standardization, there was scientific measurements,
Yeah.
and then from Sindhu Saraswati, even the Vedic times, Vedas mention all these heavenly bodies, and then there is an anga of Veda. Anga means limb. It is
Mhm.
Vedanga Jyotisha and authored by Rishi Lagadha. So
Mhm.
that was also quite uh, ancient, means it is almost from the time of the Vedas. So
Right.
our science is very, very old.
Very old. No, I mean, I have no doubt about that. And also the fact that I think, even like you mentioned right now, that Vedanga Jyotisha is based on obviously the foundation of astronomy, right? So astronomy had to be really, really, really strong in India. And also, not just astronomy, I think for astronomy, you also need mathematics to be really, really strong. So I think
Yes,
it kind of all comes together. And I do suppose that, like, lot of, there might have been lot of scientists in India who have worked tirelessly to come up with the mathematical solutions, to have mathematical and arithmetical expressions, to have instruments as well. But for this live stream, I am going to keep it slightly limited to four prominent contributors to these fields. Radhakrishna ji, can you tell us a little bit about who Bhaskara the second was, or who I guess
yeah,
more well known as Bhaskaracharya, that is teacher
yes,
or guru?
yes. Actually, Bhaskaracharya lived in the 12th century CE. CE means civil era or common era. We no longer use AD. AD is Anna Domini, in the year of our Lord, but
Mhm.
this is not in the year of our Lord. So we use CE. So,
Mhm.
and for the before BCE, it is before common era, BCE. So
Mhm.
just add a E.
Mhm.
Okay. Now,
Yes.
Bhaskaracharya lived in the 12th century CE, which is from 1114 to about 1185.
Mhm.
And he is different from Bhaskara I. Bhaskara I lived quite earlier than that. He lived in the 7th century.
Mhm.
And Bhaskaracharya was a wonderful mathematician. He was also an astronomer. His mathematical things are very interesting. So he authored Siddhanta Shiromani, and the first part of Siddhanta Shiromani he named after his daughter Leelavati. So that's called Leelavati, and Leelavati has very interesting problems, solutions. It has got arithmetic, algebra, geometry, everything is there.
Right.
And Bhaskara was also the innovator of many instruments,
Mm.
astronomical instruments, time measuring instruments,
Right.
and his Siddhanta Shiromani is widely means it is widely read. It is widely Indian astronomers,
Right.
pre-modern Indian astronomers,
Mhm.
they used it widely.
Got it. And if I'm not wrong, I think Bhaskaracharya the second, so Bhaskara second, basically Bhaskaracharya is also the one who probably also proposed perpetual motion machine at a point, right?
Yes,
Uh,
yes, he did that.
yeah, there was a combination of mercury and the wheel which would go
Yes,
on forever,
yes,
and
yes.
keep rotating
See,
on its own.
see, actually, it is very difficult. I mean, sorry, it is very easy to to think of something as a perpetually moving, if there is very less resistance and it keeps on moving, we may think that it is a perpetual motion machine. But in realities, I don't think that that is practical, because however small, there will be a resistive force which
Yeah.
will prevent it from
Correct.
moving infinitely.
Yeah, but I am extremely astonished that in 12th century he proposed an
Yes,
idea like perpetual motion machine which could go on forever. But obviously it's not possible. But at least
yes.
the idea was there in 12th
Oh,
century.
yes, yes, yeah. See, they had very wonderful ideas. For the Indians, conceiving of infinity and conceiving of zero was easy. Means it, it was not a scary thing. It was not something difficult. But other civilizations had difficulty conceiving both infinity and shunya, zero. Zero is called shunya. And in my mother tongue, zero is called Pujya, means that which is to be worshipped. Means
Weird.
zero was to be worshipped. So we have, means we don't have any problem conceiving infinity or zeros.
Zero. Got it.
The other thing there, Radhakrishnan ji, I noticed about Bhaskara too, like you're
Yeah.
saying, is that there's a Bija Ganita shloka where he has
Oh yes.
taken. And in the Bija Ganita shloka, he's talking about, a fraction of a fraction of a fraction of a fraction, where
Yeah.
he can, it's almost what we call infinitesimally small.
Yes.
I mean,
Yes.
he had a very clear perception of that, right?
Oh
And
yes.
also, like you are saying, because of the Shanti mantras like Purna Madaha, Purna Midam, Purnat, Purna
Yeah.
Mudachate, Purnasya, Purna Madaya, Purna Meva, these kind of pramanas existed in Vedas, which actually
Yes.
gave us a completely different view of what infinity means in the perceptible
Exactly.
universe. Because the
Yes.
mathematical notion of infinity is that there could be a set of odd numbers that is infinite, set of even numbers that's infinite.
Infinite.
But we had a very deeper understanding of consciousness where we could
Yes.
understand infinity as the substratum in which all these other minor infinities are appearing. So,
Exactly.
so we
Yes.
could play with this word infinity very well in
Yes.
the Hindu sampradaya. Yeah.
Right. All right.
Also, another interesting thing. I'm just digressing a little. The concept of something tending to zero means infinite decimals. Okay,
Yes.
we just learn in our schools. We say calculus was invented by Newton.
Mhm.
No, even before Newton, the idea of infinitesimal existed right from Aryabhatta's time, or even maybe earlier, from earlier times.
Right.
So we had the seeds of calculus. And also, just let me digress a little. There's a school called Kerala School of Mathematics. It started from about 1300 CE
Hmm.
and extended up to about 1600 CE.
Mhm.
Started by Madhava, Madhava of Sangamagrama.
Mhm.
Sangamagrama is a place in Kerala. It has
Mhm.
a Malayalam translation like Kudal.
Mhm.
So that Madhava speaks of calculus,
Oh,
infinite decimals. So
interesting.
just I digress a little.
Yeah, of course. Yeah, I mean, that is all still very rich information.
Just to give
So,
credit to Kerala School of Mathematics, I would like to add that see,
Yeah.
there are so many ways of calculating Panchanga. One of the way that all modern Panchangas use are Drigganita Panchanga.
mhm.
It came from Kerala schools. The gentleman was Parmeshwara or somebody
Yeah.
who
Mhm.
who did the Drigganita, who came first,
Right.
Yes.
and then
And
everybody
for our
followed.
audience, I would like to say Drig Ganita is the one that is used today, and it keeps evolving and is being studied on and researched a lot to add new mathematical calculations, and we use that for calculating Panchangam every year. Is that right, Maheshi?
Yes.
Yes.
Okay. Okay. And also, I want to ask you, Radhakrishna ji, about who is Varaha Mihira, because I think I've
Yes.
heard a lot about. Yes.
Varahamihira is another interesting character.
Mhm.
He was a polymath. Polymath means someone who is an expert in diverse fields, and he was an expert in diverse fields. And his famous kriti, his work,
Mhm.
is Pancha Siddhantika, and
Okay.
it is a compilation of different schools of astronomy. He also mentions Paitamaha astronomy, means of the Pitamahas, of the very ancient. So
Mhm.
he he starts from there, from very, very ancient days. And
Mhm.
it is wonderful that the so-called Arabic numerals, our 1, 2, 3,
Mhm.
he started from his work. Say he lived around the uh,
7th century.
yeah, 600 605 CE to about 687 CE. So
Mhm.
shortly after that, Arabs came to Sindh. They means shortly after that, Islam came up, and Arabs started going everywhere. They came to Sindh, and they ruled for a small time in Sindh. So one
Mhm.
of the astronomer, mathematicians, or I forget his name, he got this Varahamihira's work.
Mhm.
He read that, he was impressed by this our what do you call place value system and our decimal system,
Mhm.
and he translated that into Arabic, and it went over, means it spread.
Yeah.
And that's why they call the Westerners call our system as Arabic numerals. They are not Arabic, they are our own. It went,
Yeah.
and that went from Varahamihira's work.
Mhm. Got it.
So
And
that's
obviously,
interesting.
I don't doubt that because there used to be so much trade going on at the time that,
Yeah.
of course, trade is also of knowledge, right? It's not just
Yes.
articles and
Oh, yes, yes.
something else.
On that note, I would like to add. So Eashwar would know Chamaka Prashnam last Anuvaka Ekachame. You know that,
Yes,
right?
yes, yes,
That
yes.
is also all related to the number. That is part of the Yajurveda.
Mhm.
Correct, correct. Yes,
Yeah.
yes. See, other thing is, Shruti, just to your point, there's Al Mansur, who was in
Mhm.
7th or 8th century. He
Mhm.
was operating around the Silk Route
Right.
that Radhakrishna was talking about. So he was among, I think it was under his dominion only, lot of translations took place.
Yes,
Mm.
yes,
So like all this work was 6th century, right? See, other thing
yes,
which I want the audience to think about is if somebody is writing equations and
Mhm.
somebody is building crafts with the equations,
Mhm.
and we are getting, let's say, one book or maybe few books or maybe hundreds of books after thousands of years or maybe hundreds of years, we should remember what level of stability that knowledge must have attained in the society at that time
Yeah.
for this to be disseminated. We are not talking about a flash in the pan. It's not like one rare event that happened.
no,
This
no,
would have been like common knowledge.
Right.
Like
yes,
just like Boolean algebra is like common for most electrical engineers nowadays.
yes,
This would have been the Boolean algebra of those years, and they are
yes.
sufficiently advanced too.
Yeah.
And that's the impressive part about this.
Yeah,
And
for sure.
one point to note is that, see, nowadays we write everything in a short form, like uh, equations on a paper and all that.
Mm.
Those people wrote all these things, or they composed this in poetry,
Yeah.
in which was bounded by meter,
Yeah.
and which had alankaras and all that. So it, it was easy to transmit this orally. It was easy to
Yeah.
memorize the things. So all these works, or most of them, are in poetry. Science in poetry, maths
Right.
in poetry, and
Yeah.
in Vrtabadha poetry. Vrtabadha means that which is um,
Well
within,
formed.
yeah, in meter. So
Yeah.
that's quite interesting. And for that, they devised so many techniques. Certain words standing for numbers. Okay.
Yeah, I was going to say that because I think Aryabhatta, that like the world knows about him, and he has his work written as Aryabhatiya, which is,
Yeah.
it is sectioned into four pieces. One is
Yes.
Gitika Pada, one is Gol Pada, one is Kala Kriya Pada, and one is Ganita Pada, I think. So these
Yes.
four divisions, and then he has actually used letters to represent 10 raised to something, 10, like,
Yes. Yes.
and then he's used those letters to define the value, and instead of having to write so many zeros and everything, he has used that technique to be able
Yes.
to like represent bigger values in just smaller words, and it's just extremely impressive.
See, another interesting thing. See, Aryabhatta knew that at the poles, the day lasted 6 months and the night lasted 6 months. But how did he say this in poetry? He used alankara.
Right.
He used the the devas. For the devas, it is 6 months. So
Mm-hmm.
they believed, the belief at that time, the common people, we believe that the Vedas lived on the poles.
Mm-hmm.
So when he says the Vedas had 6 months, he means that the day on the pole, North Pole is South Pole. This is what the North Pole, because Devas lived in the North Pole 6 months.
Mm-hmm.
Then he said, similarly for the Pretas, Preta means ghost or demon, or so for the Pretas it is 6 months. Means in the South Pole it is 6 months day and 6 months night.
Mm-hmm.
Then another thing he said, for the Pitru, a day is 2 weeks and a night it is 2 weeks. Pitra were supposed to live on the moon. So for the moon, one fortnight is one moon day. Because
Mm-hmm.
our pragyana and all that, they work for one moon day, which
Right.
was 14 days. So
Yeah.
14 days, fortnight is one day for the moon. So he expressed all this in Alankara, in poetry.
Oh my God, that's really, really impressive. And I don't want to forget Brahmagupta because I think he also has a very significant contribution.
Oh yes,
Uh,
he was a wonderful mathematician, and he had two works, which is Brahmasphura Siddhanta and Khandakadiga. So
mhm.
both are. He was more of a mathematician, we can say, and then astronomer.
Correct.
And he also uh, he dwells on algebra quite
Mm.
a lot. See, what we are taught, we are taught that algebra came from, I forgot his name, who was al al Khwarizmi, wrote a book, Al Jabr. So
Mhm.
the Westerners say that algebra came from that Al Jabr,
Mhm.
but long before him, Brahmagupta deals with algebra, Varahamihira deals with algebra.
Yeah.
So
Okay. Yes. I mean, like I said, there is like a lot of passing of knowledge and everything. Everything was, it was a trade route. Silk Route was a trade route. So
yes,
definitely knowledge was passed from there as well.
yes.
So Radhakrishna
Also,
ji,
we may have taken some knowledge from them also. We should
of
not
course,
deny that. Both. It is a two-way street.
it's a give and take, right? It's a trade.
Yeah, it's a give and take.
Right. Okay, so I always thought that for these kind of mathematical calculations or being so precise about even astronomy, I feel like you have to have some kind of measurement instruments as well, because otherwise
Yes,
it becomes so difficult
yes,
to be able
yes,
to do or achieve something like this. But
yes.
when I think about measurement instruments, I am my mind is like, okay, it has to be very complicated and it has to be very hard to like remake or rebuild. So I also want to talk a bit about the instruments and like
Oh yeah,
talk about like what was used for
yes.
general purpose.
Yeah, yeah. Actually, instruments start right from the Sindhu Saraswati the days, because they have to build cities, and
Mhm.
without measurement, it is impossible. And of course, standardized measurement. One measurement here, unit, it should be used in another place too. So
Correct.
that's what's called standardization. Say if it is in Harappa, one unit is say this length, then far away in another city, it should be the same length. So that is standardization. So they have standardization, they have units, they have
Mhm.
measurement tools, and we see that we have unearthed weights, and
Mhm.
they found that they are all standard in the
Yeah.
whole Sindhu Saraswati civilizational area.
Yeah.
So this
Makes
the picture shows the weights and one scale for measuring length.
Mhm. This one. Yeah, and I'm so now that I think about these instruments, it's not surprising that there were extremely well planned cities, or trade was so easy because you already have units put in place to be able to
Yes,
measure like distances, to be able to measure
yes,
weight.
Okay, one question, Radhakrishna, when people were doing
yeah,
weights in those times, are
yeah.
they using like binary scale, or what kind of a scale are they using for weights actually? Do we know
They
that?
had a different book. We don't know much about the Sindhu Saraswati days. We have only unearthed some artifacts, but during the Veda time onwards, there is clear documentation, and it's not in terms of tenth. See, right now we have kilogram, uh, gram, which is
Yeah.
1,000. That was not exactly in terms of 10. It
Okay.
was the different systems. As you said, binaries were there,
Binary.
double, yes.
Yes.
And then some units had other numbers like
Yes.
12 times, 24 times,
Hmm.
Correct.
and they were based on, see, like some of them, the base, I'll say what I know, I have seen. We have a small seed in Malayalam. It is called manjadi. I don't know in any
Rati,
other
Rati,
language
Rati,
what it is called.
Rati.
This
The
manjadi
scholars use
seed,
it to call
yeah,
Rati.
red seed.
Yes, Rati, Rati.
Yeah, okay, that was used as a standard by goldsmiths. Okay,
Hmm.
so they'll say it is one manjadi, two manjadi.
Hmm.
So,
Wow.
so and then they have different names when it is certain amount, another name, then certain amount. See, like the time measurement. One is truti, the time taken to blink. From
Yeah,
that, it goes to yugas and kalpas and so on.
right,
Yes. Yes.
right.
I
That makes
think Ishwarji may know more about that.
Yes, yes, I mean, you're right, Radhakrishnan ji. I mean, when I was studying Bhagavatam and there was the slokam about all the four yugas in the time, and then we look at how many kalpas, how many manvantras, who is the rishi in which
Yeah.
one, then you can keep on seeing, and then there are other numbers which are in mathematics in those times where the dynamic range of numbers, they
Oh
Hmm.
go
yes,
from almost micro submicron level to like giga,
yes,
like
yes,
trillions of level. And I often used to wonder why did they, and sometimes these numbers are also very they are not just I am using modern language here, right? I'm saying like 10 power minus 6, 10 but those are not just base of 10. Sometimes they shift their bases, which almost
yes, yes,
means some numbers need to have a different base for certain application,
yeah,
and maybe they are commonly used for those applications. And then there are some other numbers which base of 10 probably makes sense because the numbers multiply very faster.
yes,
So I could see that society, our society, I mean human society, the Hindu society had uh, they didn't come up with these things out of context. The
Yeah,
context inspired them, and they had some prior knowledge. They built on the prior knowledge, which is pretty much how human knowledge works, and
yes,
yes,
which was really very fascinating. You're right, Radhakrishnan ji. I noticed that in the past.
So
yeah.
according to the Surya Siddhanta, the smallest is Truti. And then
Mhm.
comes
Shruti,
Tatpara, the little bigger. And then comes Nimisha, then comes Kashta, Kala, Kal, basically. And Gatika. And then 2 Gatika is equal to 1 Muhurta. And
Mhm.
then
yes,
30 Muhurta is equal to 1 Ahoratram, means day and night.
Right,
So even Vedas had some different measurement. I
right.
think Eashwar can knows he has done much research in that, starting from Parmanu Anu, right? You
Yes,
know that, right,
yes,
Mm.
yes,
Eashwar?
yes, Mahesh ji. Yes, I mean there are like very sub micro numbers that have also been used.
Yeah.
That's right. Yeah.
That's very interesting. And then also, I want to talk about, I think whenever I've done anything religious in my home for any, festival or something, we always have a setup like yajna, which is like square, or then
yes,
there is this Navagraha Puja, which goes like 9 petals of a leaf. And this is all also again feels like a lot like geometry,
yes,
basically.
yes, yes, yes. It
So,
is, it is, yeah, yeah, go ahead.
sorry, I just had a question around that not just algebra, I think geometry was also pretty progressed at the time.
Yes,
And
yes, yes,
I could, my grandmom, when I was growing up and I used to, I didn't have a free hand in Rangoli, right? Then she
yes,
would give me a string and she would say like you use that string to draw a circle,
Yes,
so that you don't have to worry about getting the exact shape by your free hand.
yes, yes,
And I think that was
yes,
also kind of used in ancient times for different purposes. So I wanted to shed a
yes.
little bit of light on that as well.
Oh yeah, yes, yes. See, even right in the Vedic days,
Mhm.
they had significance in the shape and size of the altar. Altar is a chiti. In Sanskrit, it is called chiti. So
Shiti.
different types of chitis, different types of altars they needed, different
Mhm.
shapes, the different sizes.
Mhm.
So for these, they needed measurement, obviously, and these were made of bricks. And again, they had stipulation. So many number of bricks should be used, and
Right.
such a shape, such and such a shape should be formed, and also its area. And
Mhm.
they also had certain requirements. Some circle should have the area of a square, or otherwise square should have the area of a circle. So all these requirements implied a thorough knowledge of geometry and the mathematical concepts
Right.
behind that. Say, for example,
So.
the picture shows
Mhm.
Shena Chiti. Shena means an eagle.
Mhm.
So Shena Chiti is in the shape of that bird,
Mhm.
and that has to be built. They stipulate so many bricks, so
Mhm.
it should not be more, should not be less. So how do you calculate that? You have to calculate that. You have to implement that shape. And how do they do the measurement? It is quite interesting. They you used strings, okay,
Mhm.
and these are all mentioned in Shulba Sutra. Shulba means string. Shulba.
Mhm.
There are different Shulba Sutras, and they are almost as old as the Vedas.
Mhm.
So these are all mentioned in the
Sure.
Shulba Sutras.
Yeah,
How
one
to
question
make it.
I had with this earlier, you said like, you want to have the area which is exactly same as a square, you want it for a
Yes,
circle. I
yes,
think there is also some easy way to do that for common folks as well, right? You don't really have to be, like
yes, yes.
mathematician or anything to do
No,
that,
no, no, no.
right?
See, they have technique. That's why they say how to use string for that, to construct that.
Right.
Even I know. See now, our masons, you know, they check the right angleness of their construction. It is just they see three here, four here, and check whether it is five.
Yeah.
Just with the strings.
String. Yeah. That's amazing. I think string is such an easy instrument, like not even instrument, it's just everyday stuff that you have at home. You don't
So
have to go anywhere for that.
so when you talked about string, right? So this I have seen Radhakrishnan ji where I think I didn't know this till I read the translation of Sulba Sutras, but
Yeah.
some of the mestris, we call them, right? The masons who come and build and all.
Yes. Yes. Yes.
If they are trying to build something of a certain area, and then
Yeah.
the shape changes,
Yeah.
but the area remains the same. So the
Yes.
question will come: how do you construct a new shape with the same area?
Yes.
So for that, they had some rule of thumb.
Yes.
With their measuring tape, they used to do this, and they used to do it very fast.
Mhm.
Yes.
Even the
Yes.
normal kids would probably write an equation and go to paper or
Yeah.
something.
Yeah.
Then later on, when I read Sulba Sutras, there is a Sulba Sutra that talks about how shall I say this correctly? How to square a circle.
Trans- yeah.
Like how do you? And they will do string techniques. Then I realize it is
Yes.
running in our sampradaya. People have
Yes.
are
Yes.
aware of this. So,
And like I said, like it has so many applications, obviously applications in physics, but it could
Yes.
also be as simple as using it in Rangoli, right? You don't have to even
Yes.
use it
Yes.
for complicated purposes. So I
Yes.
used to feel so happy that I got a perfect circle because I had like one string and one finger like pointed with the string down, and I could just move that and don't have to worry about it. And it's perfect.
that is also physics, Shruti.
Yes.
That's also physics. That's also physics, math, and geometry. All.
Exactly.
And
Yeah.
and aesthetics thrown into it.
Aesthetics
Yes.
as well.
Yeah.
Yes,
Yeah,
that's right.
Aesthetics. Yeah.
I
rasam.
mean, I shouldn't say this, but I feel like I'm very horrible at freehand in general. It's really not my piece of cake. So something like this is super useful to me to feel good about like being a little artistic at times. We have a comment. I just want to showcase that
Yes.
Vidishri here is saying that it's completely unfair to kids when they are introduced to physics, geometry, and they aren't made aware of the proper origin, the contributions of Aryabhatta, Bhaskaracharya, and these are truly phenomenal. Thank you so much,
Yes.
Vidishri, for
Yes.
that comment.
Yeah. Yeah. That's a very good comment. And see, I myself, I can say that I did not know of Aryabhatta when I was in school.
Right. Yeah. I
I
think
actually I first heard of him in ISRO when I worked in ISRO. That's
right.
when
I
I
heard about
started
him in
really.
Ayuka. So there is in Pune, there is an astronomical center called as Ayuka. I forgot the full
Yes.
form. That is
Yes.
where I was like, what, like whose statue is this thing, And then they're like, oh, you don't know him? He's Aryabhatta. And then I was like, okay, I need to know more about this person, and that's how I also found out basically. Okay, so moving
Just
on.
just one thing on the previous thing. The
Yeah.
Radhakrishnan ji talked about different altars, right? So, like for
Yes.
example, this Shena Chitihi is Indra. For Indra,
Okay.
invoking Bhagavan Indra,
Okay. Okay.
that was the thing they will use. For Soma, they'll use circular. They will use
Yes.
Chaturam for Agni. So, like for each of the Vaidika Devatas, so which means every shape had an application in the form of the invocation.
Hmm.
Yeah.
Upasana, Agni
Hmm.
Upasana was there. So, which
And for
means,
Devi, they will use Yoni Kunda. There are triangular shapes, there
yeah,
are different
yeah.
things. And
In fact, there is a
Pentahedral
semicircle. There's a
circle.
semicircle also for
Yes.
Varuna,
Ardha Chandrakar for
Ardhachandrakar.
welfare.
Yeah. So it is,
I say this to my friends all the time that for me, there is no separation between science, religion, and God, right? They all seem so connected to me when I look at something like this. And
Yes.
but that is also a sign of maturity, right? When a civilization, when humans have lived in a certain part of
yes,
the earth for a longer period of time, they've had the opportunity to evolve to a certain level of maturity.
yes,
Yeah,
for
right.
sure.
Yeah.
Yes. So,
And actually,
one
there
of
is a book on that one on Yagnakunda Vidhanam, which will say exactly how much it should be. And usually, whenever you do the Homa, and the Yajman's hasta, how the using his hand, measurement of his hand.
yeah,
Yes. Because the Yajaman has to sit there and do
that's
Yajman
the.
has to
Oh,
sit there. According to his hand, the
that
whole measurement is made.
is done. That's amazing. So another interesting thing for measurement, I feel, which obviously is very very foundational in every science, is the measurement of time. Now I know that some of the books that I read, they talk about India in sixth century knowing about the time that cannot be measured because we don't know when it started and when it will end, and there is the time that we can measure, which is like
yes.
day and night. There could be the duration between sunset and sunrise, moonset and moonrise, and there are so many things that you can use to measure time. So let's also talk a little bit about that.
Oh, yes. Yeah. Because measurement of time is as old as civilization. People started.
That's correct.
People had to measure
You had to,
time.
yeah.
Yes.
Yeah, and
And
one thing I feel that recently I traveled. I had a chance to travel to Phoenix City in the US, and they have a botanical garden where there is a shadow clock like the one shown in the picture, and obviously it's a day clock, so it is only from like 6 a.m. to 6 p.m. in the evening.
yes.
But its rod is angled in such a way that the shadow exactly tells you what time it is right now based on the sun's
Yes.
movement.
Yes.
So
Yes.
that's pretty astonishing. I think we had something similar way back. So
Yes.
let's also talk
Exactly.
about that.
Because time measurement is important in astronomy also. Means they have to actually uh, what do you call relate the observation and the time when it was observed for further calculations for coming up with new hypotheses or new theories. So time measurement is very much a part of astronomy too.
Mhm.
So the first time measurement attempts were made by measuring the shadows, the shadow of a gnomon. Gnomon is called Shanku in Sanskrit.
Mhm.
So, uh, depending on the shadow, they can tell that time. But we think it is very, very simple. No,
Yeah.
there is a lot of trigonometry and spherical trigonometry involved in calculating. So when shadow falls at one place, what
Mhm.
is the time? When shadow falls at another place, what is the time? For
Right.
that, you need trigonometry and spherical trigonometry. So
Right.
they had ideas of trigonometry,
Mhm.
and they calculated. They made sundials. They made different mm, things with. And also, Shanku comes in different shapes. Also, this is a simple Shanku. We have different Shankus like triangle or could be many other shapes. And
Right.
Shanku has also another use. See, the sun moves north south. It's called ayana. Like
Mhm.
Uttarayana means moving north,
Right.
Dakshinayana moving
Moving.
south. So from the movement of the sun, we can say where exactly the sun is with respect to the fixed stars, in which zodiac the sun is.
Right.
So that technique
Yeah.
with this simple gnomon, with this simple Shanku,
Shanku.
Yes.
we can use the simple Shanku for that. So finding
Right.
out in which zodiacal section the sun is.
That's right.
I think
And it's
Can
also
add something to
Mahesh
it.
ji can say more about this.
Yes,
right.
because that is what we used in Panchangas. So Shanku in olden days was to calculate essential differences. The essential, so the essential difference, we will go into that later on. But basically, the ascendant is the rising sign on the eastern horizon.
Mhm.
So usually, when the sunset to sunrise, there are take place. If sun rises at 6 and sets at 6. So
Mhm.
in Lankodayamana, basically 0 degree latitude in the Lankodadaya, not really Sri Lanka. It's got nothing to do with it, right?
It's a
Yeah.
fictitious
So
island.
the essential difference will be the each ascendant will take exactly 2 hours. But when you go north, and south, the during the summer, it will increase and decrease. So
Yeah.
so during the midday, the length of the so that Shanku is always it's a wooden stick made of 12 fingers,
Mhm.
12 anguls.
Right.
So that's how it's been measured, and then that's how they calculate essential difference.
Correct.
Basically, essential difference is the Lankodaya, basically from the 0 degree of latitude to the latitude of your place,
Correct.
whatever time it takes, because sun is here, during the when because Earth is tilted, right?
Yeah.
So if your location is here, it will go straight. But if your location here, it will take more, right?
Yeah.
Somewhere. But on
Yeah.
the 0 degree of latitude, it will go up, it will be all same.
Same. That's right.
Okay. So it will be whether sun is here, 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 or here.
Yeah.
Okay.
Yes.
So using that, that essential difference is being calculated. Now
Yes.
Correct.
to calculate sunrise, sunset, this essential difference is being used.
Got it. And one more thing I would like to point out, which I think could be easily missed, right? That is the fact that, to explain to our audience who is joining us for the first time, with geocentric model, you have Earth in the middle because we are on Earth and we are observing what we can from Earth. And then we are saying, okay, there is a big, imagine a big circle outside the Earth, which is divided into 12 pieces, which we call as zodiac, because each of them have a certain collection of stars that we have given names to, like Leo, Libra, and so on. And so we are saying that we can easily spot in the night sky where the moon is, because we can see the constellations and say that,
Yes.
okay, moon is in this zodiac right now. But how do you do it for the sun? Because there is no there is no stars at that point. So I think this
Right.
Shanku that you just pointed out, this
Yes.
Thaya yantra, which is used along with the Shanku, is able to tell that in which zodiac is the sun right now, and without
Exactly.
any stars,
I,
right?
I I would like to highlight one complexity here. Like
Yes.
sometimes when we look at instruments like these, in today's time and age, we tend to think, oh, it's a very simple instrument and they did a lot of calculations with it. But then, if it is really a simple instrument, then you have to do a lot of calculations with it, which basically means the like Radhakrishna, when you said it is when I really thought about it. Trigonometry, they would have definitely had to have some cognizance of it. Otherwise, you can't really do this. But
Yeah.
depending on where the Earth is in its journey around the sun, the
Yeah.
rate of change of shadow will vary at different times of the year. And you talked about
Yes.
Uttarayana, Dakshinayana.
Yes.
Now you are
Yes.
actually talking about variables uh,
Yeah.
whose differential you are measuring, not the
Yes.
variable itself. So which means
Yes.
birth of calculus is, you can almost see the birth of calculus here, because
Yes. Yes.
the rate of change of shadow depending on which time of the year you are moving, that
Exactly.
has to
Yes.
be cognized. Either you have to
Yes.
calculate it or you have to log it. Like in the old days
Yes.
when I used to go to write engineering exams, they used to give a log book where they used
Yeah.
to have
Yes.
log
We
tables,
had that.
right? So log tables
Yes.
will be there. So similarly,
Yes.
must have created a series of lookup tables of some kind
Yes.
to be able to
Yes.
understand. Otherwise, it's not easy to predict. Imagine they're doing daily planning with it: when to eat, when to sleep, agriculture,
Yes.
temples, shadow, vastu shastra, and then of course a lot of the other, quasi-religious and
Yes.
religious stuff that we have in our lives.
Yes.
That's right.
So this has to be very complicated math.
So
Yes.
Surya Siddhanta has sine, cosine, tangent, all those
Yes.
tables.
Yes.
Yes,
Surya
Yes.
yes,
Siddhanta has all of them. Even
Yeah.
Graha Lagava has also all of them.
Yeah.
yes,
So
Yes.
I mean, our
And the very
ancient
word
system was
sign came
very rich.
from India.
Is rich.
But I will not say about that. I just leave it to the viewers to find out.
Yes, for sure. So, one more thing, Radhakrishna ji, about India is, it's unfortunate that we don't have any museum which can show us,
Oh, yes. Yes.
all of these instruments used and how they were used. Even today, we can just recreate these instruments and show it to the general public that, hey, this is how you use this instrument for. But I think something very amazing and wonderful is the fact that some of the architectural buildings itself, they could be thought of as instruments as well. Am I right?
Yes. Yes. See,
Yeah,
that's exactly what our Jantar Mantar is.
slide. Yeah.
Jantar Mantar has different yantras
Mhm.
based on our ancient texts.
Mhm.
And Maharaja Savai Jai Singh
Mhm.
built this, I think in such a 1700s, like 1730, between 1730 to 1750 CE.
Ji.
So I went there and I've seen the shadow telling the correct time.
Time.
See, and you see the
Yeah.
picture, that structure is a gnomon.
Mhm.
Behind me and my wife, there
Yes.
is a structure, that is uh, gnomon. That is one yantra. Similarly, there are other yantras there
I think they are
of
all in the
different.
same place. There are like multiple instruments, like
Yes, yes,
buildings, which are
yes,
actually instruments, and they are placed
yes,
in the same park. And you could figure out like
yes,
cardinal directions. You could figure out with
yeah.
the shadow. You could figure out the time, and then I forgot what this main building is for.
This one, this is a sundial. The one that
Yeah,
is behind us
yes.
is a sundial.
It's the
interesting.
largest sundial, I think, in the world. So
Yeah.
Largest sundial. Nice. So
That
I would,
slant is the gnomon. That slanting structure
yeah,
is the gnomon. See,
no,
it is parallel to the latitude, or
right.
not exactly parallel. The gnomon is parallel to the latitude.
Right. I mean, this is already an architectural wonder, right? You
Yeah.
could easily use this to even tell time. Like anybody could just walk to this park and they could tell time. They could tell so many things
Yeah.
based on where this thing is. And I feel really bad because as a child, I visited this and I zero understood what it means. I just thought it's a funny looking building and I visited and came back. But next time I go to India, I'll definitely visit this
Yeah.
again.
Actually,
See,
there is a
this is one
temple
thing
in
which we
Kerala called Sri
not.
Padmanabha Swami Temple. On the day of the equinox,
Oh
you
yes,
will say that sun is appearing sequentially through each
Mm.
yes,
window of Gopuram
yes.
of
Ooh.
the
One.
Sri Padmanabha Swami
Yeah.
Temple. Think about how much mathematical calculations they have
I
done.
Yes.
know.
It is
Oh,
not possible without any mathematical
mathematics.
knowledge.
Yeah. I think everything comes down to mathematics, right? Everything like architecture comes down to
Yes.
mathematics, all of these astronomy, Jyotish Shastra, which is Vedanga, all of them eventually come down to mathematics.
And
So,
if you don't believe me, please go visit Padmanabhi Swami Temple on the day
Yeah.
of equinoxes, which will be
Yes.
like March 21 and September 22nd.
Yeah.
Go
right,
and visit early morning and see, you will see.
right.
Witness it.
yeah, and similarly, Brihadishwara temple also, Mahesh, is that
Yes.
that's a, it's a topic in into itself. But on top of it,
Mm.
what I would say is the shadow of the big gopuram, right? It will never
Yeah.
fall on the ground, even if the sun goes above. They've
Oh,
built it in
Oh.
such a way they anticipated that the shadow will never fall, except It's not like entire year it won't be the case, as we talked about earlier.
Yeah.
During certain times of the year it will never fall, and those times of the year are special and you don't want it to fall. So it's
Yeah.
done with that, you know, calculus in mind.
Wow. Which temple is that again, Ishwarji?
Tanjavur
Brihadareshwar
Brihadishwara. Tanjavur
in Tamil
Brihadishwara.
Nadu.
Tanjavur. Okay, okay.
Tanjavur.
Amazing. Yeah, I
Tanjavur is
mean,
city of temples. Remember.
yes,
And
yes.
Tanjavur cooks are also really good. If you want to eat somebody's house, make sure the food is cooked by a Tanjavur cook.
I will. I will. I think my India bucket list is just never ending now. I have so many places to visit.
Oh yes.
Yeah. So, for our viewers who are watching this shadow instrument or Chaya Yantra for the first time, I want a little bit more explanation on how the sun's shadow helps in telling the time or the zodiac. Radhakrishna ji, if you can explain a bit.
Oh yeah. See, actually, the gnomon is, as I said, it can come in different shapes. Let us take one simple gnomon, which is a stick. Okay, so that stick stands vertical, and as the sun moves, as the sun goes from east to west, that's how the time changes. So the shadow, length of the shadow, and the direction of the shadow changes.
Mhm.
But uh, they keep the length. They design the dial such that the change of length is not an issue, but the change of direction is what measures the time. So they calibrate the dial accordingly, and then there is a correction table for seasons. As seasons change,
Mhm.
because of the ayana, because of the movement of the sun from north to south and south to north, there are changes. So that change is also shown in the sundial as a
Oh.
function of time, as the year progresses, how
Mhm.
much change should be applied.
Mhm.
So uh, these all need calculations, as I said. So they have calculated and they've done everything and just calibrated the dial to
Yes.
show the time based on the
Mhm.
shadow's direction. Then the other thing we talked about, as to where the sun is, in which zodiacal constellation the sun is,
Mhm.
that is told by the length of the shadow at
Ah,
noon.
okay.
Madhyana means noon. At noon, what is the length? So as the sun moves from north to south, the length varies. And from that, we can say where exactly is the sun. See,
Mhm.
we think that the sun is exactly at the zenith in the noon. No.
Mhm.
Depending on the season, it changes. And also, depending on the latitude, it changes.
Yes.
Okay. So
Yeah.
they have calculated all that. And with that, they can say from the length of the shadow, oh, the sun is in Aries, or the sun is in
Oh,
Aries is Mesha, sun is in Mesha, or sun is in Mithuna, or sun is in whatever
correct.
zodiacal. Uh,
Yeah. That is amazing. And especially because you already also know the correction that you have. Because I think, okay, the apparent path of sun as viewed from the earth is, I feel, very, very complicated to understand.
yes, yes,
So
yes, it is.
they have explained it and they also have applied the corrections to it, which is
Yes.
amazing. So yeah, let's also go to water clocks. I think water
Oh
clocks
yes,
are really, really interesting to me because
yes,
I imagine that there is always this logic of volume being dispersed and as you immerse something in water. But I think here the Jala Yantra is specifically again calculating time. So do you
yes.
want to explain, Radhakrishna ji, how the Jala Yantra would work?
Sure, sure. See, Jalendra, they have to come up with the Jalendra because the sun is not there in the night. When the sun sets,
Exactly.
how do you tell the time? So Jalendra is based on, it means two things. One is uh, how much time a bowl with a hole at the bottom takes to sink down in another bowl, another vessel with water. So uh, that is called the Ghatika Yantra, Ghati Yantra, Ghatika Yantra. So
Right.
that's a small Ghati. Ghati means the small. See, you in the picture you can see two vessels. One big vessel
Mhm.
filled with water, and another small vessel floating in that. That small vessel has the hole in the bottom.
Yeah.
So water enters that small. The small vessel is called Ghatika. Ghata means a
Pot.
pot.
Or,
Mhm.
Ghatika means a small
Smaller
vessel.
bowl.
So water enters that slowly, slowly. Water enters and it slowly goes down, and finally it fully sinks.
Immerses.
So
Yeah.
what time it takes for it to sink? So they make the dimensions of the Ghatika and
Mhm.
dimension of the hole
Right.
such that it sinks in 1/60th of a day. 1/60th of a
Mhm.
day is
That
the
is
old
24
is
minutes.
Right.
24
the
minutes.
yeah, yes, 24 minutes. That is also called Ghati, Ghatika.
Mm.
Okay.
And I believe then the word ghadi from in Hindi or ghadiyaal in Marathi has come from this word which is
Yes,
ghati
yes,
and it's immersing.
this is
I want to ask to Eashwar, what do you call gatti in Telugu?
same only. Same.
Gatti?
Gadiyam. Gadiyam. Will say.
Gadiyam.
Ghadi.
name. Yes,
Mm.
everything in, in all languages the word comes from this
This
Ghadika.
one.
And then another another set of instruments is based on slightly different thing. It
Mhm.
is the water going out of a small hole at the bottom of the tube. A tube is called nali in Sanskrit, nalika.
Mhm.
So nalika has water in it, and the water. See again, the dimensions are all calculated such that the water goes down, and they have marked. They have markings. So from one marking to the other, it takes one ghati.
Mm.
That they call one ghati. So, but
Ghadi.
the very name of the instrument has also come to the unit of time. So one ghati is also called one nalika, and in
Mm.
my mother tongue, it is called narika. Slightly
Mm.
different. A sound called ra. So
Mm.
In Tamil
nalika has
also,
come from
Radhakrishna ji. In Tamil also, Narigai.
So
yeah, narika.
all the
Yes,
Panchanga Agamas, Dharma Shastra, they also use the word Nadi, not Gati. Like
yeah,
for
nadi. Yes,
Naga Panchami, they say Nago Dwadasha Nadi Bihi. Means
yes,
12 Gatika, you
yes,
have to basically the
Right.
Dwadasha Nadi Bihi.
yeah,
Nago
So
Dwadasha
this is
Nadi
actually
Bihi.
interesting because if we compare both these vessels,
yes,
clearly the one above is more complicated than the one below because it's made up of two vessels.
Yeah.
yes,
Second,
yes,
right? Second thing is the
yes,
fact that there is a it is the smaller vessel that really helps measure in the context
yes,
of the larger vessel, which means the time unit is also smaller there compared to
yes,
Nalika. So it's
Mm.
yes,
possible that Nalika is the longer time measuring device and
yes,
Gatika is
yes.
Smaller
so
time.
It's
and
the
sometimes
smaller
longer
time.
means yeah, longer
Yeah,
means sometimes you don't need too much precision also, right? Like you could say,
yeah,
when are you going to airport? You say 3 hours before, right? On the
Yeah.
other hand, you say, when is the flight leaving? You say in 2 minutes. You know, I mean, these are two different things. So you
yes,
use
yes,
one instrument for maybe very precise measurements. Maybe
Mhm.
use one measurement for maybe generic, measurements.
yes.
Bigger,
And
longer.
there's also one interesting thing. See, in the olden days, I think even kings and especially Buddhist mathas, they made known the time. So what
Mhm.
they do, they do this. What do you call
Hitting
ring
the
a bell
bell.
or
They ring the bell.
strike a gong. Strike. It's called so ghanta nadam. Okay.
Yes,
From
yes.
that comes the Hindi word ek ghanta, do ghanta.
Yeah.
Okay,
Yes.
so but actually it is not really hour. It was every ghadi they that
Yes.
ghanta,
Makes
and
sense.
then the day was divided into four units, equal
Prahara.
division. Okay,
Prahara. Mhm.
prahara. It is called
Yama.
prahara, and in the night it is called yama.
Mhm.
So again, when one prahara was over, the ghanti will be very loud.
Right.
So why the madhyana, why the noon is called dopahar in Hindi? Because
Mm.
do pahar,
Prayer.
2 pahars have passed.
Oh, that is so interesting. Oh my God.
Yeah.
You use language every day, right? But you never think of it in this sense.
Yes. Yes.
Very interesting. I am actually very curious, Radhakrishna ji, why is 24 minutes so important as a time unit?
Again, see, they all based this on 60, the system of 60. The
Mhm.
day was divided into 60, and also one circle was divided. They divided one circle into 360. See, our 360 degrees, etc., come from very very old system
Yeah.
of
Observations.
measurement.
Mhm.
So
So if
they,
you
and
think
also
that Gati is that
the
just a
beauty of it
24
is,
seconds is the 24 minute is the thing, there is the one smaller than Gati. It's called Pala. And then that
yeah,
is 24 seconds. And
Yeah.
then there is a smaller than that, which is called Vipal. So we use
Vipala.
that in calculating the horoscopes. I have used it a lot.
Yeah.
Right. Okay. Okay, understood. All right. So let's now talk about, Bhaskara the second, who is also known as
Oh yes,
Bhaskaracharya.
yeah.
And
This
he
is
had
very very interesting.
Right. He
Okay,
had a
before
couple of
before starting,
interesting instruments, and I just want to point out to the viewers as well that today we talk about sustainability and not wasting any resources or water. I see that in all of his instruments or models, there is always a bowl that is also collecting the water. And we are talking about an era where water is abundant, everyone is getting as much as possible, and we are still saving even like a bowl of water, which we are using in the instrument, but we want to reuse it again. So that's
yes,
also a genius of Bhaskaracharya.
yes,
But yeah, please explain what these
yes.
instruments are.
Also, one more thing, I'll add to what Shruti ji said. Bhaskara was also interested in making it simple, so that
Mm,
it could be reproduced accurately. Means it could be manufactured easily and accurately and standardized. So it has to be simple, and all these instruments are simple. So
simple.
this water wheel is interesting. Okay, before that, I just got these pictures
Mhm,
from from a source which is mentioned just in the bottom. It is
Sanskriti magazine.
Sanskriti website.
mhm,
So we changed it. Of course, we didn't copy the pictures. We changed a little so
mhm.
that you can easily understand things. Uh, but we acknowledge the source.
Yes.
Now, Bhaskara's water wheel is uh, it works on the principle of water flowing to a container, and the
Mhm,
container, as the container gets filled, it moves. These containers, 4 containers, are fixed on a wheel. So
mhm,
with the weight of the water, the container moves. And if you see there's a tube with mercury,
yeah.
and when it tilts, mercury moves to the other side, adding torque to the rotation, and the wheel
Mhm,
gets
Flips.
one movement, a
right.
jerk. Okay, and then when that happens, the other bowl comes in the way of the water. Now that gets filled, then
Mhm,
another jerk. So this wheel keeps rotating in jerks, and the thing is, the the water from the bowl, when it
mhm,
comes down, it is collected in a bowl at the
mhm.
bottom. So
Yeah.
water gets collected, it can be reused.
Right.
So it keeps on rotating, and they adjusted the dimensions, the amount of mercury, everything, such that each jerk will be
Yes.
some unit of time. It can be a ghatika,
Mhm,
means 24 minutes. So
mhm.
One question, Radhakrishna ji.
simple. Yeah,
In this diagram, I see four of those cups around the wheel, right?
yeah. Four are there.
So, which means there must be, they are dividing whatever they are measuring into four parts then.
Yes, yes.
Mm,
Okay. So, if you
Four
want to do
parts.
24
So
hours, like for example, then you need 24 cups and
yeah,
corresponding amount of water, corresponding size of diameter.
yeah,
mm.
So, as you are
yeah.
measuring maybe
Small.
longer duration, the device may actually get bigger.
Bigger and bigger.
Mm.
Yes.
Yeah. Okay.
Definitely, yeah, it has to get bigger.
and lot of mercury at the same time, right?
Yeah.
Right.
Correct.
So
So
also
do you
from
have
my
plenty of mercury in the olden days?
Mhm.
Mercury was used for many things. Even see, rasayanam,
Cyanide.
rasayan. Rasayan is
Medicine.
a medicine. It has a
Mhm.
little mercury, and mercury is considered as harmful now. But that
Mhm.
small amount of mercury may not be harmful. I mean,
I
so
think
many
this question is
rasayans are there in
this question
Ayurveda.
should be going to Dr. Shalinder Sodhi,
So
because
deeply.
that Ayurvedically how much mercury, but we will say, guys, do not consume mercury.
Yeah,
Not advise it. It is rasayana, but
yeah,
always, and it is not as it is. Okay, it was
yes,
processed,
yes.
and so much modification is done. So
Oh,
do
yeah.
not do it without any doctor's
Yes,
advice,
exactly.
please.
Yes,
Exactly.
for sure.
Because
And mhm.
these are all done in medicinal quantities, very small. And they
Right.
say sputa. They do sputa. Sputa means some sort of
Clarification,
process.
processing,
Mhm.
Sputa in
Burning.
Sanskrit
clarification.
means
Burning on high
clarify.
heat. Yeah. High. Yeah. You're
Yeah,
right. Sputikaranam basically means you are
yeah,
burning it, or
Burning.
you're
Mhm.
yes,
sterilizing it, or whatever you call it.
yes,
In yeah.
yes.
Got it.
So,
It also means
so don't take mercury. That,
Yeah. One more thing I wanted to point out here is I think he has used this concept of wheel, at least from my research and the books that I've read.
yeah,
He has used a similar concept of wheel itself, like chakra, and then he has that specific balance of mercury and water to be able to propose an idea of perpetual motion as well,
yes,
where it
yes,
will balance the weight because then the mercury will slip to the other side and the
yes.
wheel will keep moving
It keeps
with
on
those
moving.
smaller jerks.
Yeah.
Yeah.
See, it
So,
can keep on moving for a very long
time.
time,
Right.
which we may consider as perpetual, but it will stop sometime
Yeah, I
because
mean,
there is
it's
a
maybe it's like it can be made to think of a perpetual motion, but not
yes, yes,
actually
yes,
perpetual motion. Awesome. And yeah, this one I find very, very interesting,
yes,
which is from Aryabhatta. And I
yes,
believe this is the globe that moves with the same speed as Earth during the day. So this was
yes,
extremely surprising to me about how this apparatus was built. So yeah, please shed some light on this.
yes. Actually, two things you must remember. See, first, this instrument itself. Second thing is that Aryabhatta knew that the Earth is rotating,
Correct.
okay, on its axis. At that time, not many people knew. See, we learn in textbooks that I think Copernicus or somebody or Galileo, I forget. He was the one who said that the Earth rotates. But no, this was so many centuries before them that he has recorded it very clearly. So that's another thing. Now we come to the beauty of this
Wow. Yeah.
yantra itself. So you know
Mhm.
how it works. There is this tube, this nali with a
Mhm.
small hole,
Mhm.
and there is water in it, and there is a weight. Again, there's a little mercury in the weight.
Yeah.
That's how it balances, but it floats. So as the
Mhm.
water level goes down, the weight pulls the string. The weight goes along the water.
Mhm.
It pulls the string, and that
Mhm.
string makes the globe
Globe.
or rotate. And the dimensions and everything, the weight of the thing and
Mhm.
the amount of water, everything is adjusted. Even the dimension of the hole has to be adjusted such that
Mhm.
this completes one rotation in one day. Means Earth's. It is exactly simulating the Earth. But at
Earth.
the same time, what Aryabhatta has done, wow, he actually marked the string with small notes so
Mhm.
that you can count one note. Each note
Oh.
is one ghadi, one unit of time, and as it
Mhm.
moves, say 1 hour means what, or whatever time unit,
Yeah.
1 hour is passed, one ghadi is passed, second
Yes.
ghadi is passed, third ghadi is passed.
Right.
So that can be uh, you can tell that the time with
Yeah.
this
You would know
yantra.
exactly what portion of the day you are in right now because you could
Yes,
count the
exactly.
knots and you could know that by
Yes,
that. Okay.
yes.
Yeah.
Also, there was another technique where they calibrated the tube with
Mm.
the time. But then you'll have to look into the tube to see the
Yeah.
time. But the notes on the string you can easily see.
See, that's right. That's just, this one was just like, I was very, very surprised and very happy to see this one, that there was something which could move with the speed of Earth in 6th or 7th century. That is
Yes.
crazy to think right now. And again, like, I want to point out the genius of Aryabhatta here. Radhakrishna ji, someday you and I have to also talk about his four padas, which he has
Yeah.
documented. I want
Yes.
to point out the genius, because this is such a simple apparatus. Again, you just have to know how
Yes.
much water, how much weight, and
Yes.
that's it. Like, you could do it at home if you wanted to.
Yes.
So it's
And
just
also,
very,
this
very
equipment is very scalable equipment. Like it's a
yeah,
very,
Yes.
it's very
very
scalable.
scary.
It's very, I would say, relatively compact.
Yeah,
And
Yes.
yeah,
you don't have to like have an industry to make something like this. You
Yes.
could just make it at home also, if you knew the
Yeah.
exact dimensions and the weight that needs to be used. All right, so this one is the sand clock, and I think this one might, like, a lot of our viewers might already know about, but we can still talk about it. Because मुझे याद है when I was growing up, and there was this thing about like newly installed showers in the bathroom, and
Yeah.
then you could go on forever in the bathroom. So there were these sand clocks of 10 minutes or 15 minutes, and they were like, please use this and know that you have to finish your bath within that time. Don't go on wasting time forever. So this was pretty commonly used, but where is it mentioned again, Radhakrishna ji?
Yeah. This is mentioned in various texts.
Hmm.
Uh, they call it Renu Garbha.
Hmm.
Renu means sand. Garbha means a vessel. So this is a vessel with sand. Even our Bhaskaracharya mentions this.
Hmm.
Varahamihira also mentions this. So it is mentioned in different texts.
Right.
The time is measured by the movement of Renu. Renu means sand
Hmm.
from one part to the other part. Now
Right.
the same thing is done in glass. We see such things, such hourglasses.
Hmm.
But in the ancient days, I think it was made of brass or copper,
Right.
and it was not transparent. So you will have to look into it from the top to
Hmm.
see the amount of, and it was calibrated, so you can see how much time has passed.
Very interesting. Again, I think this is, again, this is something I would like to point out to our viewers one more time, that for measuring the same thing, we have multiple ways and multiple devices. And there are, obviously, this means that there was a lot of research in how this thing could be done using XYZ, using ABC, using something else, and we are doing the same thing. We are still measuring time, but we're using water sometimes, we're using sand sometimes, we're using sun and his position sometime to see the shadow and realize. So this is all extremely fun to look into. All right,
That's
and
very,
now, yeah, sorry, Radhakrishna ji.
yeah, no, that is very interesting, because we have multiple ways of measuring things, and
Mhm.
also it is confirming. You measure with one equipment and you measure with another equipment, and they should say the same thing.
Thing,
So
yeah,
it is
exactly.
confirmation also.
Yeah. So there is also this angular measurement related devices, which again seem like, so they're simple, and so I call them genius, because anybody could use this to measure. So let's see how to measure something using this device.
Yes. This was mentioned by Bhaskaracharya, but it has it was in use from very ancient days.
Right.
So the first is the Chapa Yantra.
Hmm.
The you look at a heavenly object
Hmm.
along a road. There's a road, and you look at it, and also it had a plumb line. So the plumb line will be vertical,
Hmm.
and there was a calibrated protractor like thing.
Hmm.
So you can measure the angle,
Mm.
the angle. So this actually we
Okay.
measures the angle from the vertical of
Hmm.
the heavenly object you are looking at, and
Hmm.
from that also you have to move it. There are two angles involved. One is called azimuth and one is called elevation. So this is measuring elevation, and you can measure the azimuth from how much it has moved from, say, from the true north, how much you are moving from the true north. From this, you can calculate the position of the heavenly body on the celestial sphere. It's called celestial sphere. Also,
Yeah.
there's no sphere there. It is just an imaginary
Right.
sphere.
Right.
So, what is the angular dimension? I mean, means the angular position of the heavenly object.
Correct.
So,
Yeah. That's
this is for
again.
that.
Yeah, and I can see that the string will always drop down, right? Because I
Yeah, yeah.
think it
It
has
will be vertical.
right,
So
because it has slight weight at the end, so it will always
Yeah.
be vertical like that. And then you are
Yes.
saying, okay, I have something like a telescope or a doorbin, and I'm saying I
Yeah.
want to measure that star, so I'm holding it at a certain angle, and the string is
Yes.
still vertical, and then I'm able to measure the angle between
Yeah.
them.
It easily tells the angle because it is calibrated. That
The
protractor
protractor thing, yeah,
is calibrated.
got
And,
it.
and also, like since you said telescope, imagine Shruti, you're looking at one object now,
Yeah,
then maybe you're looking at another object now. So you
yeah.
can do the relative, angular
Yes.
distance between those two objects now.
Yeah.
Yes. Yes.
And again, very, very simple to build. I am just amazed by that, that anybody could have it.
Yeah.
It doesn't seem like a very complicated apparatus, to be honest. It's
Yes.
Oh,
and
which
it's a
means some of
horizontal
these.
coordinate system actually. So from that you can get the longitude, latitude,
uh,
right ascension and
Yes.
declination also.
yeah.
Yes. Yes.
So I will request Eashwar to go ahead. Sorry to interrupt you.
No. Mahesh, you said something else now that triggered another thought for me. Like, so for example, you said latitude, right? Like, to do latitude, you have to look at Dhruva Nakshatra, though, right? So we
Yeah.
can use this to measure Dhruva Nakshatra, the angle, and relative to that, you can measure every other object.
Any angle.
Yes. Yes.
So you can measure latitude, you can measure the sine of the angle, the cosine of the angle,
Yeah.
and sometimes you can. It's like equations, right? You will do a little bit of
Yeah.
trigonometry and apply some algebra and figure out the unknowns. So it's a very powerful idea
Yeah.
for us.
And also very simple, again.
Very
Very,
simple.
very simple to build.
Very
What is
simple.
this other yantra that we see, which is like a ring,
Oh,
Radhakrishna ji?
that is much more simple. It's a ring. It
Mhm.
has holes diametrically opposite, two holes. Okay,
Okay.
and the idea is first you see the rising sun's position east,
Hmm.
true east, or
Hmm.
maybe even you can see setting sun's true west. It
Right.
shows true sun's position, and then you change, you rotate, and you rotate it to look at heavenly object through the two holes. You you
Mm-hmm.
you'll have to look through the hole, two holes. So that angle, it's also calibrated again. So as you tilt, as you rotate the ring to see the heavenly object, you can read the angle. You can read the
Oh.
vertical angle, and then again how much you moved from the true east direction, that
Hmm.
is the azimuth angle. So you get two
You
angles,
mean true
azimuth
north,
angle.
right? From the true north, right?
Yes,
Mhm.
yeah. Not
Okay.
the true, yeah, so whichever that
Uh,
direction. They
Hmm.
actually set it with sun because it is easy.
Yeah.
Sun rises in the east.
Hmm.
So from that you can calculate the position of the angular position of the heavenly object.
Makes sense. Yeah, and also you need something for reference. So I think
Yes.
rising sun is basically a reference that this is the point that
Yes.
you're measuring it from, and then
Yes.
whatever angle you want to measure it at, it would be easy to
Yes.
calculate that. Mhm.
Yes.
This
So
is
just
possible.
They look simple, but they are really ingenious.
Yes. Sorry, Ishwarji, you were saying something?
no, on the previous slide, Shruti, this is just again a curiosity question. Is that when we are observing any object which is
Yeah.
close to the horizon,
Hmm.
right? There is a certain amount of refraction of light that takes place.
Yeah.
So
Yes.
Hmm.
and then so we did. Is there any textual evidence, Radhakrishnan ji, which actually shows that they took that into account?
I don't see that. I mean, I think they did not. They might have, because without that errors will creep in
Correct.
their calculation. So they might have, but there is no mention in these.
It is called
Correct?
Vakri Bhavan Sanskara. It is called Vakri Bhavan Sanskara, the atmosphere
Oh, is it
reflection.
okay?
Mhm.
Vakri
Okay,
Bhavan
okay,
Sanskara. It is there in the pretty much Surya Siddhanta and many other
oh,
books.
okay,
Mhm.
okay, okay, okay.
Okay.
Then, yeah,
Very
because
fascinating.
without that, errors will creep in.
Especially for the ones on the horizon, right? Because we'll
Yeah,
Yeah.
yeah, but not if it is higher, that error is very, very, very less.
All. Yeah.
correct.
Makes sense. And then I also want to talk about this one because Yashti, from what I know, is like a stick, and
Yeah,
you're using a single stick for measuring height of some object that you're
yes,
seeing at a like far away distance. How
yes,
does
yes.
that even work? Like this is so simply, this is just genius.
So simple.
Yeah,
Yeah, again, this was mentioned by Bhaskaracharya, and Bhaskaracharya says that he got it from ancient
yeah.
times.
Mhm,
So this has been there from a very, very long time. It
mhm,
is very simple. So say let us say a mountain or a tree far away.
mhm,
So he looks at the bottom and draws a line.
mhm,
Okay, then he looks at the top
mhm.
again through the stick because this stick is pivoted, so it can move
Move.
like this. So
Mhm,
he looks at the bottom,
mhm,
draws a line, looks at the top, draws a line. Just these two are enough. From
mhm,
this, the bottom thing, he can calculate the height using this
mhm.
equation. It is simple geometrical thing.
Yeah, this
Like
is so like I am so amazed by this because I think they have also taken the height of the person in account, right?
yes,
And
yes,
it doesn't matter then who is using this instrument. The calculation would still be the same because your height is also considered in that
yes,
because
into
that would be the
yes,
point. Yeah, and
The
you don't
baseline. Yeah.
move closer to the actual object. You don't have to be anywhere near the object to measure that
yes,
height. That just amazes me so much.
yes, yes, yes.
Okay.
See, they thought of all these simple things. They see now when we look at it, it is simple. But to
Yeah, yeah.
conceive of a simple thing is a very difficult thing.
Of course, like I think the brilliance is the fact that it is simple.
Yes,
Otherwise, I mean, I know that these kind of calculations would be so complicated that you would have to build an apparatus. It wouldn't be so easy for common man to build something like this. But I feel like the genius is in making it very very simple and easy to understand and also easy to use. Like anybody could have Yashti in their house and they could use
yes,
this yantra to make those calculations. So I almost want to use this to measure the wall, the wall that I have.
yes,
I get a tape and I try to measure it like 10 times, and I feel like this could just save a lot of time for me.
yes, yes. Mhm.
Amazing. So I think we have
So
discussed a lot of instruments so far.
yes,
So do you also want to mention like other,
yes.
scientists?
See,
Mhm.
actually, our discussion was mainly focused on astronomical and mathematical instruments,
Correct. Yeah.
geometry and all that. But we had plenty of other instruments too. For
Mhm.
example, Sushruta. Sushruta was a surgeon. Okay, he
Mhm.
lived about 2,600 years ago, and his Sushruta Samhita. It's a work he authored.
Mhm.
He has mentioned so many different types of surgical instruments specific for each kind of surgery. He has mentioned which instrument is to be used for which surgery. And
Mhm.
the first time I saw this, see, one of my cousins was doing this Ayurveda degree course. So I happened to see his textbook, and there so many instruments were shown. This was so many years ago, like say
Yeah.
50 years ago, 55 years ago. So I asked him, what are these?
Mhm.
So he said, these are the drawings of instruments
Mhm.
described by Sushruta for surgery. And there were so many of
Yeah.
various shapes.
Yeah. So yeah, I agree with you. Like we only mentioned because we only have limited time for this live stream.
Yeah.
So we focused on astronomy and mathematics today. But certainly, like if the audience is interested and they write to us, I would love to have another session also talking about the surgical instruments and the interest in that. So for sure, we should also go to those. And I think even though we are ending this live stream with these instruments, there is something that we want to give the audience or the viewers as a homework.
Yes.
So Radhakrishna ji,
Yes.
you want to explain a bit?
So, first question. See, we speak of sine theta and all that, cos theta, sine theta.
Mhm.
Where does the sine come from? Let I request the viewers to do
Find
some
out.
research and find out how
Yeah.
the word sine came
Yes.
about.
And if you,
Yes.
I would like to tell the viewers, if you are watching this and you find all of this interesting and you actually go and try to find where this word originated from, so please post in the comments of this live stream once you find out where it has come from. And we'd love to get back to you. Radhakrishna ji is very, very eager to circle back on things. So please write to us if you find out the answer. The next one is, I think, Bhaskaracharya's book Leelavati, and he's asked a mathematical question. So do you want to explain that, Radhakrishna ji?
Yeah. It's a simple question. See, a peacock is sitting on a pillar,
Mhm.
and the peacock sees a snake.
Mhm.
Okay, and the snake is 3 times the height of the pillar. It is away 3 times the height of the pillar, and the height of the pillar is 9 hasta. Hasta is a unit of measurement.
Okay.
So uh, now the question Bhaskaracharya asked his daughter Leelavati,
Mhm.
tell me quickly
Yeah.
at what distance
Mhm.
the peacock and the snake meet
Mhm.
as the snake moves towards its hole.
Mhm.
Uh, if the distance covered by the peacock and the snake are equal.
Okay. So what we are saying is there is a hole here where I'm pointing right now, this arrow which says peacock and snake meet here. And this distance is the same as a line that you might draw from the peacock until this point.
Yes.
So this is what we are
And
saying.
the
We are saying, what is that distance?
yes, and the distance from the pillar
Mhm.
base to the snake's original position is
Position. Yeah.
3 times the height of the
Pillar.
pillar.
So if height of the pillar is 9 hasta, then this one is 27 hasta.
Hasta.
Okay, that's the
And now
unit.
you calculate. See, Bhaskaracharya says, quickly, tell me quickly. Can you say quickly?
Yeah, I don't think you have to be like maybe daughter to Bhaskaracharya to be able to answer this quickly, but we'll give our audience more time to find out the
Yeah.
answer to this, and we'll Radhakrishna ji, you should post the answer to this after a while. Maybe we can give
Yeah, I'll
7 days,
do it.
and
Yeah,
then we'll post the answer in the comment section.
yeah, sure.
Awesome. So I don't see any pressing questions from the audience at this point.
Okay.
So I think we can. I want to mention the references for sure, because Radhakrishna ji here has done a lot of research to be able to come up with all of these instruments, mention where these instruments were mentioned, the texts, the ancient texts, and the books on the ancient texts. So all of these are the references to that. And also thanks a bunch everyone for joining in
Yeah,
today. We
thank you
would
all.
love to have you back on our streams talking and discussing about so many different topics. Thanks a bunch for asking questions. Thanks a bunch for posting your comments. And then we will see you soon in another week. And we would like to stay connected with you. So please share your thoughts. If you're not live and if you watched it later, please leave your comments. We would love to have more sessions of the topics that the audience also might be interested in. So please post to us, and of course, like, share, and subscribe to our channel, and keep meeting with us, and also please post your comments.